Welcome to educational channel of Suresh Bhatt classes. We are going to solve permutation and combination NCERT class 11th chapter 7 miscellaneous exercise question number 3. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of part 1 exactly 3 girls, part 2 at least 3 girls, part 3 at most 3 girls. Solution part 1 exactly 3 girls. 3 girls can be selected from 4 girls in 4C3 ways. The committee has to have 7 members. It means that the 4 boys are to be selected. So 4 boys can be selected from 9 boys in 9C4 ways. Therefore, total number of ways committee can be formed equal to 4C3 multiplied by 9C4 ways. This is equal to 4C3 can be written as factorial 4 upon factorial 3 into factorial 1, that is factorial 4 upon factorial 3 into factorial 4 minus 3, which is equal to factorial 1, multiplied by 9 factorial upon 4 factorial into 5 factorial. 9C4 can be written as 9 factorial upon 4 factorial into 9 minus 4 factorial, which is 5 factorial. So this can be solved like this. Factorial 4 can be written as 4 into factorial 3 upon factorial 3 into 1 multiplied by 9 factorial can be written as 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial upon 4 factorial can be written as 4 into 3 into 2 into 1 into 5 factorial. So we cancel the 3 factorial of numerator by 3 factorial of denominator and 5 factorial of numerator by 5 factorial of denominator. And we cancel 3 into 2, which is equal to 6 of denominator with 6 of numerator. And we cancel the 4 of denominator by 4 of numerator. This gives us 9 multiplied by 8 multiplied by 7. This is equal to 72 multiplied by 7. 7 times 2 is 14. We write 4 and carry 1. 7 times 7 is 49 plus 1 is 50. This is 504 committees can be formed. So this is the answer of the part 1 of the question, that 504 committees can be formed in which there will be exactly 3 girls and 4 boys. Part 2 at least 3 girls. So there will be 2 conditions for at least 3 girls. The first condition will be there will be 3 girls and 4 boys, and the second condition will be there will be 4 girls and 3 boys, as the maximum number of girls available is 4 girls for this question. So part A we write in part 2 of the question. Part A 3 girls and 4 boys, for which we have already solved in part 1 above, equal to 504 committees. 4 girls can be selected from 4 girls in 4C4 ways, and 3 boys can be selected from 9 boys in 9C3 ways. So 4 girls and 3 boys can be selected in 4C4 multiplied by 9C3 ways, equal to factorial 4 upon factorial 4 into 0 factorial multiplied by 9 factorial upon 3 factorial into 6 factorial. This is equal to 4 factorial upon 4 factorial is 1. 1 multiplied by 9 factorial can be written as 9 into 8 into 7 multiplied by 6 factorial upon 3 factorial can be written as 3 into 2 into 1 into 6 factorial, and we cancel the 6 factorial of numerator by 6 factorial of denominator, and also cancel 9 by 3 of the denominator for 3 times and 8 of numerator by 2 of the denominator for 4 times. So this is equal to 3 multiplied by 4 multiplied by 7, which is equal to 84. Therefore, total committees that can be formed equal to 500 by 84, which is equal to 588 committees. So, answer for the part 2 of this question: when there are at least 3 girls in each committee, the answer is 588 committees can be formed with at least 3 girls. Part 3 of the question: at most 3 girls. It means that there can be 0 girls or no girls in a committee. There can be 1 girl and 6 boys in the committee. There can be 2 girls and 5 boys in the committee, and at most 3, that is, there will be 3 girls and 4 boys in the committee. So we write part A: 0 girl and 7 boys. This can be done in, this is equal to 4C0 for the selection of girls and 9C7 for the selection of boys. So this is equal to 4C0 is 1. So we directly solve 9C7, that is equal to factorial 9 upon factorial 7 into factorial 2. 9C7 equal to factorial 9 upon factorial 7 into factorial 9 minus 7, which is equal to factorial 2. This can be written as 9 into 8 multiplied by 7 factorial upon 7 factorial into 2 factorial can be written as 2 into 1. So we cancel the 7 factorial of denominator with 7 factorial of numerator, and we cancel 8 of numerator for 4 times by 2 of the denominator. So this gives us equal to 36. 9 times 4 is 36. So 36 such committees can be formed in which there is no girl and all 7 boys. Part B: 1 girl and 6 boys. This can be done in one girl can be selected in 4C1 ways, multiplied by 6 boys can be selected in 9C6 ways. So this is equal to 4C1 can be written as factorial 4 upon factorial 1 into factorial 3, multiplied by 9C6 can be written as factorial 9 upon 6 factorial into 3 factorial. This can be written as 4 factorial can be written as 4 into 3 factorial upon 1 into 3 factorial, multiplied by 9 factorial can be written as 9 into 7. 9 factorial can be written as 9 into 8 into 7 into 6 factorial divided by 6 factorial into 3 factorial can be written as 3 into 2 into 1. So we cancel the 3 factorial of numerator by 3 factorial of denominator and 6 factorial of numerator by 6 factorial of denominator. We cancel 4 of numerator by 2 of denominator for 2 times, and 3 of denominator cancels 9 of numerator for 3 times. So this is equal to 2 multiplied by 3 is 6. 6 multiplied by 8 is 48. 48 multiplied by 7. 7 times 8 is 56. We write 6 and carry 5. 7 times 4 is 28. 28 plus 5 is 33. So 336 committees can be formed in which there is 1 girl and 6 boys. Part C, 2 girls and 5 boys can be selected in 4C2 multiplied by 9C 5 ways. 2 girls can be selected from 4 girls in 4C2 ways multiplied by 5 boys can be selected from 9 boys in 9C 5 ways. This is equal to 4 factorial upon 2 factorial into 2 factorial multiplied by 9C5 can be written as 9 factorial upon 5 factorial multiplied by 4 factorial. So we cancel the 4 factorial of numerator by 4 factorial of denominator, and we further solve like this. 9 factorial can be written as 9 into 8 into 7 into 6 multiplied by 5 factorial upon 2 factorial into 2 factorial is 2 multiplied by 2 as 2 factorial equal to 2, and again 2 factorial equal to 2 multiplied by 5 factorial. So we cancel the 5 factorial of numerator by 5 factorial of denominator, and we cancel 2 into 2 of denominator, which is equal to 4, which cancels 8 for 2 times. So this is equal to 9 times 2 times 7 times 6. So we write 9 multiplied by 7 is 63 and 2 multiplied by 6 equal to 12. So this is equal to 63 multiplied by 12, and on multiplying 63 by 12 we get 12 times 3 is 36. We write 6 and carry 3, and 12 times 6 is 72 and 3 is 75. So this is 756 committees can be formed with 2 girls and 5 boys. And part D, 3 girls and 4 boys equal to 504 committees from part 1 of the question. We have already solved this condition in part 1 of this question. Total committees with at most 3 girls is equal to 36 plus 336 plus 756 plus 504. So this gives us 6 plus 6 equal to 12 plus 6 is 18 plus 4 equal to 22. So we write 2 and carry 2, then 3 plus 3 is 6 plus 5 is 11, and we write 11 plus 2 is 13. We write 3 and carry 1. 3 plus 1 is 4 plus 7 is 11 plus 5 is 16. So this is equal to 1632 committees. So part 3 has the answer. There will be 1632 committees in which at most 3 girls will be there in forming the committees. Here completes this video. Please like, share and subscribe to this channel. Also press bell icon to get the latest notifications.